Okay, well, hello and good morning and happy Wednesday. We'll get started. Today's topic, we will introduce matplotlib. Matplotlib, kind of the library that we use to power a lot of our graphics and any kind of data visualization in Python. Now. I am biased, and I'm a big fan of ggplot in R, and in my opinion, ggplot is the kind of superior version of being able to do data visualization. But matplotlib is quite capable, and you can read up on it. So what you will do is you will import matplotlib.pyplot as PLT, and this is going to kind of form the base command that we will be using. So here I go, importing matplotlib.pyplot as PLT, also importing NumPy and pandas in standard form there. And let's just create a very simple plot to start with. So I'm going to start with a set of values for x, and I'm going to just go from 0 to pi, 2 pi, multiply and have kind of 500 values. So this is just going to be linearly spaced. And then I'm going to plug those values into the sign function. Okay, and so we got x is 500 values in an array, and y is going to be 500 values. Yeah, question. Oh, you know what? I apologize. I forgot to push to GitHub, so thank you for that reminder. That's why. All right, so git push. Oh, I'm sorry. Gotta commit them first. Okay. Okay. So now I've pushed them to GitHub. If you do a fetch, they should appear. Fetch upstream. And then fet merge upstream main. That should work. Are we good? Maybe? Here, I'll double check. Yeah, they're there. Okay. Okay. So x is a NumPy array, 500 values. Y is also a NumPy array with 500 values. And so to create the plot, we will call plt.plot x comma y. Okay. So this is kind of your basic form. plt.plot x comma y, or matplotlib.pyplot.plot. Okay. And then to make it appear, you call plt.show. All right. plt.show is kind of like calling print on the plot. In Jupyter, you don't technically need to call plt.show. The plot will still appear, but it's generally good practice to call plt.show. In Jupyter, the default behavior of Jupyter is that when a plot is produced, to kind of just have it show up. Okay. You can also there's other functions that you can call to modify the title or change access limits and things like that, and you would call that before calling plt.show. All right. So here I call plt.plot x comma y, and then I'm going to add a couple options I'm going to do plt.title. The title of the plot is going to be sine of x. If I didn't do that, it'll just be blank. And then for the x limits, I will go from 0 to 2 pi. If I didn't do this, matplotlib kind of automatically figures out what the limits should be. Usually it puts a little bit of kind of padding on the ends, so the lines won't go all the way to the ends. There will be a little bit of white space here. Okay, and then I call plt.show, and it prints out the plot. Okay, if you so when you call call plt.plot xy, its default behavior is to kind of just connect them with dots. So here I'm going to take values 0 through 4, 0, 1, 2, 3, 4, and here I'm going to just pick 5 random integers, right? And they end up being 3, 2, 2, 7. And so if I do plt.plot, it connects 0, 3, 1, 2, 2, 2, 3, 7, and 4, 0. Right? And so this is kind of the default behaviors of plt.plot and plt.show. It connects the points with lines. There's no title here, and then you can see there's a little bit of a gap between the end of the line and the edge of the plot window. Okay. Whereas over on the previous slide, I adjusted the x limits, I changed the title, and so these are the differences that you get. If you want to take the same dots, but you don't want them connected with a line, you can call plt.scatter. Okay, plt.scatter will take those same exact locations, 0, 3, 1, 2, 2, 2, 3, 7, 4, 0, and it will just do dots instead. It's dots instead of connecting them with a line. And so that's what we have. With matplotlib, you just have to kind of learn the vocabulary for what is the command to create a line plot, what's the command to create a scatter plot, things of that nature. And so, whenever you use matplotlib, you'll probably have to have another window open for the API reference, okay? The reference, the documentation for matplotlib. You can, if you call plt.plot multiple times for different kind of sequences, they will add them to the same plot until you call plt.show. So here I've got x being an array of 500 values from 0 to 2 pi, evenly spaced out. And then I'll say y is sine of x, z is tangent of x, w is cosine of x. And if I call plt.plot x comma y in blue, it'll plot sine of x in blue, and then I'll call x comma z in red is going to plot the tangent of this, okay? And then when I click show, it puts both of them on the same plot, okay? And here it looks like the blue line is just flat, but that's just because the scale in the vertical direction is thrown off by the values of tangent, right? And true tangent at pi over 2 goes off to positive infinity and negative infinity, and so those can't actually be plot. Apparently because we spaced them out at these kind of discrete points from 0 to 2 pi, and we have 500 of these things. Apparently over here we got maybe something around 120, and over here we got negative 300. So that's why they're not technically going off to infinity or negative infinity, but still it's enough to kind of make the sine of x appear completely flat in this graph. All right. So, but over here, if I plot, plt.plot xy and plt.plot xw, okay, we can see sine of x in blue, cosine of x in orange, and it looks like the way it's supposed to be. All right. And so, every time I call plt.show, it kind of clears out what the plot looks like. And so these become new things. So successive calls to plt.plot just kind of adds more to the picture. All right, so let's talk about modifying some of the options on our plot. So one of the things you can do, so by default, if you look at what's on here, what's annotated, nothing is annotated, right? You do have axis tick marks in the x direction and tick marks in the y direction, but there's no label as to what x represents or what y represents or anything like that. So if you want to add labels, you have to call plt.title, plt.xlabel, plt.ylabel, and you just put whatever string you want, and that will appear as your x label, y label, y-axis label, and your title. Okay, and so I think that's fairly straightforward, but that's how you would do it. And again, all of these commands, you just have to kind of learn them and become accustomed to how they're being applied. You can also change, say, the x limits. Okay, and so here for the x limits, I'm changing in to 0 to 2 pi. I wonder why. Okay. I was expecting this to go all the way to the edge, but perhaps it didn't work out. This is one of the options is to change the aspect ratio, plt.axis, and so axis equals should put these on the same scale. 0 through 4 would have the same distance from -2 to +2 because there's a difference of 4 units, and so this spot should be kind of a square, and it does appear. Versus over here, 0 through 4 goes over here, but the vertical distance is only 2, right? From -1 to +1, this vertical difference is a difference of 2, and that's at a different kind of scale level. So it's kind of like stretched out vertically. So if you were to take a picture of a circle and put it over here, it wouldn't look like a circle. Over here, it would look like a circle. A few other options is you can change, say, the marker or the color of the dots. So here's a scatter plot, okay? And so as far as the scatter plot goes, I'm plotting x and y. Here my limits are going to go from 0 to 0.2, and you can see these are individual points. So the marker down here for the sign, I've got D for diamonds, and then up here I have H for hexagons. All right, and I'm not expecting anybody to kind of memorize any of these things. We've got like a little table of a reference. You can also specify the colors. This is maroon. There's some named colors: dark slate, gray, things like that. And so you can control basically what your plot looks like. So some of the options that you can do is you can change the color of your plot lines. So you have one-letter shortcuts: blue, green, red. There's quite a few. There's, I think, a handful of colors that have one-letter shortcuts. Other colors have, full names as far as what you can specify. So here I'm just calling x plus 1 and x plus 2, to plot this. So these are kind of your single character color shortcuts. You got blue, green, red, cyan, magenta, yellow, black, and white. And then as far as, let me open this up, list of named colors. These are all kind of the different colors that have been named. So you have maroon and fire brick and lemon chiffon, dark slate gray, light slate gray, medium purple, Rebecca purple. Okay, I have no idea what any of these colors are, but but these are the different colors that are named. You can also, just the single letter colors, this is kind of your base colors here, all right? You can also change maybe the line style, okay? The default behavior when you call plt.plot is to use different colors anyway, but you can also change the line style, and you can use words like solid, dashed, dash dot, and dotted. You can also just kind of put in these symbols. So if you just put in a single hyphen, that will be solid, and actually that's kind of the default line style, so you don't even need to specify anything. If you want it dashed, you just put in 2 dashes on the keyboard, right? You just enter dash dash, and that will give you a dashed line. If you do dash dot, which is what we see in green, which goes dash dot, you can enter a dash dot in quotes. And if you want dotted, you put in a colon, because that looks like 2 dots in a row, and that'll give you the dotted line, which shows up in red. Okay, and there's more specifications as well. So let me. So as far as different line styles go, you got solid, dotted, dashed, and dash dot. But you can also kind of specify this with numbers, kind of with tuples, the spacing of all of these things if you want different line styles, and you can read through the examples on how to do this. Okay, so matplotlib is fairly well documented, and so there's lots of examples as you go through the documentation. You can find lots of examples of generally any plot that is produced here. This is a plot produced by matplotlib. This will be the exact kind of code that was used to produce this. And so these are the specifications for how the line style is produced. Let me give you your first quiz answer for today. Today's first quiz answer is the letter C. C as in cat. C as in cat. Okay, so want to look at a few more options. So here I'm just going to create a scatter plot of 100 random dots. Okay, I've got 100 random values from 0 to 1, 100 random values for 0 to 1 for y, and then here I'm just plotting x and y. And so here's a scatter plot of a bunch of kind of 2-dimensional random uniform values. You can specify how big of a figure you want. So here I'm doing figure size 4, 4. Now these numbers 4, these are just kind of like imaginary units for the screen. I don't exactly know what it would correspond to in say real life. Okay, so here I've got 4, 4. I don't know, maybe it's 4 centimeters. I have no idea. Okay, so I specify the size of my figure first. Then I say I'm going to create a scatter plot of x and y. I want the axes to be of equal size, 0, 1, 0, 1 on the same scale. Add the title. Let's show the plot. Okay, and just like everything else, you can look up more documentation on specifying your figure. So here I just used figure size. Okay, but there's a whole bunch of other ones. Okay, so figure size, probably the first thing, the default I guess is 6.4, 4.8. That's your default figure size. So if you look at some of these other things, this would be 6.4 by 4.8, whatever size this is. And here I got 4 by 4. And other things you can specify is the dots per inch, face color, edge color, other stuff like that. Okay, so if you wanted to say have a plot where maybe you wanted different colors, maybe your data has different groups, okay, and some of these groups or some of these dots belong to the red group, and some of the dots belong to the green group, and some belong to the blue group, or something like that. Well, you can modify the color. All right. You can also modify the size of each dot. So perhaps, I don't know, maybe you're plotting stuff about different countries around the world, okay? And so maybe you want the size of the dot to represent the population of the country. So, China, India, United States, we would have big dots, big size circles. Smaller countries would have, smaller circles, smaller dots, okay? And then maybe you color them by continent, and you'd say, the Americas show up in red, and Europe shows up in blue, and Asia shows up in green, or something like that, okay? And you color the different dots based on continent or something. So you can kind of specify, you'd have to have a vector, or an array with kind of that information. So this first array we will use to specify the size, and the size I've got going, 1,000, 600, 500. And then this other array we will use to specify the color, okay? And then to kind of turn the colors into so this array of numbers, which I'm going to use into colors, I've got a color where now this array represents the color that I want to use, okay? So the first dot will appear as green, the next dot will appear red, the next dot will appear blue. Here I'm using the single letter colors, but you could replace this with any kind of any other name that you want, okay? And notice the way I've created this array of colors is I started off with an array called colors, and I had R, G, B, M, Y, and then I'm subsetting. I'm calling colors based on this vector W. And so the first entry in C is going to be index 2, which will be green, okay? And then I have index 0. The second value has value 0, so it's going to be R. The next value has a value 1, so it's going to be B. The next value has a value of 4, which corresponds to Y. All right, and so if I apply this and I say make a scatter plot using X and Y, S for size, I'm doing S, size is equal to this array Z, and C for color is equal to the array color, C. This is the plot that I get, okay? Alpha just modifies the transparency of each of the dots, okay? And it might not look like this. Here I've modified the figure size to be 8, okay? It might not look like it, but if you kind of look at some of these patterns, say there's these 3 circles over here, and there's kind of a cluster of points over here, these are the same X locations, okay? These are the same X and Y locations. The dots are in the same position. You can see there's kind of a gap right here and a gap in this top right corner, and that still exists in this thing. It's just all we've done is we've taken each dot and we've changed the size of each dot, we've changed the color of each dot. And so you can kind of apply something like that, and therefore you can create a plot where you're communicating multiple variables, right? Maybe, again, if this were like different countries, X could be GDP, and Y could be life expectancy, and you could have, some dots, the size representing the population of the country, and the color of the dot representing, or the color of the circle representing which continent or region they are from, things like that. Okay, so you can communicate multiple of these things. The unfortunate thing is that matplotlib doesn't automatically create legends or anything like that, so you would have to kind of figure that out. All right. You can also change the print markers. So again, same information. Here, I'm saying instead of circles, let's use stars. So I'm putting marker as a star, and now I got stars everywhere here. Okay, and this kind of looks like we're just having a party, but that's what you can do. There's a bunch of other kind of markers that you can use. The default is the point, but you can also have circle, triangle up, triangle left, triangle down, hexagons, diamonds, and you've seen some of these. And again, the marker reference is right here, and these are some of the different markers you could use as far as what you want plotted. Okay. And then there's also, you can also have the markers filled in different styles, the top or the bottom and things like that. Okay, so again, just I will point you to the reference. All right, so here I'm creating a legend, and so here I'm just going to say, here, let's say we have two groups, a group A and a group B. Group A I want to represent with red stars, and group B I want to represent with blue circles. And in here, I can do this. I have my X data, size is 100, color red, marker stars. The label is group A. Over here, I got blue, markers being circles. The label is group B. And when I call legend, it puts it by default up in this top right corner. So that's a possibility. Let me go ahead and give you your second view quiz answer. Today's second view quiz answer is E. E as in elephant. E as in elephant. Okay, you can create complex layouts with subplots. So I mentioned this here because sometimes you might see something in someone else's code about subplots. The matplotlib documentation likes to create subplots, but to be honest, this is a real pain, okay? And it's not fun at all to have to create subplots and try to use subplots. But here I'm creating a subplot, and so to make things even more confusing is matplotlib is based off of, it's called matplotlib because it's based off of MATLAB's plotting capabilities. Okay, so MATLAB's another kind of computer language designed for doing mathematical work, and the author of the matplotlib library based it off of MATLAB's plotting ability, and MATLAB is a one-indexed language like R, whereas Python is zero-indexed. And so when you do things like subplots here, the plots end up being one index. So anyway, here's this thing we're going to call subplot, and we say I want 2 rows and 3 columns of subplots, but then this first one over here is the index 1 subplot. Top left is index 1, and it goes across the row. So this will be index 1, index 2, index 3, and then index 4, index 5, index 6. And then you specify which one by saying we're looking at plot in the 2x3 structure, 2 rows, 3 columns, I want to work in plot 1. Or in the 2x3 2 rows, 3 columns, I want to look at plot 5. And plot 5 refers down to here. And so this is kind of this is what we've done, right? One of the things that I've called subplot to specify which plot we're working in, and then to kind of add the label, you just call plt.text. Plt.text will add just text to the thing. So this, the only thing I'm plotting at position 0.5.5 is, some string, plot 231, and so on and so forth. All right, so this one got cut off. But here's an example of what you can do. So if you want to create sine of x versus cosine of x and tangent of x and sine and cosine, you can do this. And so the command here is I say I want subplots 2, comma 2, comma 1, indicating I want a 2 by 2 arrangement of plots. And the first one I want it to be sine of x. Okay, and then the second one I want the title to be cosine of x. And each of these things, you know, I call a new subplot to say I'm working in this corner. So when I call this last subplot, subplot 2, comma 2, comma 4, I call plt.plot red and plt.plot blue, and so both of those things get plotted in this one, and I say sine and cosine. Now you can see the titles of the plots, you know, and this is another reason why this gets so frustrating, is that the titles of these subplots end up running into kind of the axis labels of the plots above, all right? So some of the default behaviors of subplot are just a little bit frustrating, and it's really kind of painful to get it right. Here's just a more complicated one. Like, don't even bother, to be honest. Just make separate plots. That would be my recommendation, unless you're like really insistent on, I need to get this to work or something. Okay? So there's another more complicated thing that I only mention in passing, but you know, if you insist that you're going to use Python and you're going to use matplotlib to produce the plot that you want to produce, you might be able to do it by using something like grid spec. Okay? Unfortunately for grid spec, that uses zero-based indexing. So what grid spec allows you to do is, here you say, I want to create a plot structure of 2 by 3. I want a 2 by 3 plot structure, and then I want one of my plots to span, to be in the first row, so that's the row, zero index row, and I want it to span columns like using a slicing notation. I want to span from column index 1 colon column index 3, which basically goes from 1 to 2 inclusive. So that's what I'm saying here. So grid 0, comma 1 colon 3, and then I'm saying make a histogram here. And so now I have a plot that spans kind of 2 columns. So you can kind of imagine this 2 by 3 grid structure, and you say, oh, I want a plot that spans these 2 columns. Over here I have a plot that spans these 2 columns. Okay, so this is grid 1, comma colon 2, so it spans the first two things. Anyway, it can be done, but my goodness, what a pain this is. Okay, but it exists. Yeah. Question? Yeah. You can only do one graph per cell, but you can, within one graph, you can plot multiple lines and things like that, right? So you can add things, but yeah, per cell it's just one plot. Now there's a lot you could do within a single plot, but it's just going to be one plot per cell. Okay, let's talk about histograms, just because that's such a common data visualization that we want to do, and that's very easy. You just call plt.hist. All right, so there's some just this will create your default histogram for some data. So here I say just give me 1,000 standard random normal values. Okay, center at 0, standard deviation 1, and so this is the histogram that I get. This is the default settings if you just call .hist on an array of data. Okay, there's a few options you can change. So matplotlib, you could alter how many bins you have, and so you're going to say bins equals 25. Now this is where like your vocabulary gets mixed up as you're working in different languages. R uses breaks, and matplotlib uses bins, and I can't tell you how many times I've typed in breaks into matplotlib and I get errors, or I type in bins into R and I get errors, and you just have to kind of put yourself in the headspace. Okay, so here I'm specifying the number of bins. I'm changing the transparency level, alpha equal to 0.5. You could specify your color. That's going to be the fill color, and then the edge color of the bins is given by edge color. okay? Which is quite a bit different from R. In R, color for a histogram is usually the edge color, and then the fill color is called fill. But here you go. This is what it looks like. The same data from here, just we've changed the properties of the histogram. Okay, if you this is another style. So if you don't want all of the bars in between, lines in between, you could do this. This is called step fill, and so it doesn't draw the internal lines between bars. But you can see this is the same plot, just we removed those things here. I turned off the transparency, and so that's what we have. And then yeah, here is more documentation covering the histogram and some of the options that you have. So you can, draw and return a probability density, things like that. You can do that. All right, so here, what did I do here? Okay, here I've created three arrays of random normal values. Okay, so array 1 is mean 0, standard deviation 0.8. The next one we had a mean of -2, standard deviation 1, and finally we had a mean of 3 and a standard deviation of 2, and I asked for 10,000 points for each one. Here I create a dictionary of keyword arguments. And this is going to kind of specify the arguments I want for all of my plots. Histogram is step filled, alpha is 0.3, density true, density histogram. So rather than the counts, density will be, they scale them so everything has an area of 1. Bins 20, edge colored black. And then using the same arguments for all of them, I can unpack the dictionary as arguments that would go into plt.histogram. Okay, so normally in plt.histogram you'd kind of give it a bunch of keys and values, right? Histogram equals step filled, color equals steel blue, edge color equals black. Okay, and pretty much inside here I can use Python's magical ability to unpack a dictionary into a bunch of keywords, keys and values. And so I'm going to unpack all of these things, and I'm going to say, for this one, PLT, I want the color to be navy, and for the other one, I want the color to be purple. And this is what we get, okay? So this is, with alpha 0.3, this is navy, and this is purple at 0.3 alpha, and this is your kind of your default blue color in alpha. And so you get this, this little plot here. And so this is kind of a nice little feature of unpacking your dictionary. Right. There's other things you can create, two-dimensional histograms. This is a hex bin histogram and stuff like that. I'm going to kind of just blitz over these because I don't think you're going to use these as often. But here I've created x to be 0, 1, 2, 3, and y to be -1, 0, 1, 2. Okay. And here I'm calling a function, and the function is going to return x times y. Now this function of x and y can be as complicated as you want it to be, right? It could be say a normal density, a two-dimensional normal density, right? A multivariate normal distribution, and that'd be a much more complicated function. But basically you can just have this function f return some kind of thing. Now what I'm doing here is I'm calling mesh grid. Okay, mesh grid is going to kind of create a whole bunch of values of x and y where I can then apply this function to x, y. So this will create an array, okay? An array where I'm applying the function to this top left is going to be, x is 0 and y is -1. And then the next one here, I've got x is 1 and y is -1, x is 2 and y is -1, x is 3 and y is -1, okay? Next row is x is 0, y is 0, x is 1, you know, so it's applying these, right? So you can think of this as going down kind of the x being 0, 0, 1, 2, 3 across the top, and then -1, 0, 1, 2 kind of going down the rows here. And we got this grid of values. And so anyway, this would be a product of two normal distributions, something kind of like that without a normalizing constant. You could create a contour plot of this. You can create, well, you know, a kind of a two-dimensional density plot, something like that. Okay. More importantly, I want to say pandas. If you have pandas loaded and matplotlib loaded, you can call plot directly from different pandas series. Okay. So here I've just created like an imaginary time series starting on January 1st, year 2000. Okay. 1,000 days from there, which I guess goes to September 26, 2002. And I said, just give me some random values here, random normal values here. Okay. And here I'm going to create a time series where, or I create another column where I'm going to take the cumulative sum of this thing. Okay. All right. And so the cumulative sum of all of these values of 1 and negative and positive and all of this, you know, this kind of gives me a random walk. And so if you have a series, you can call ts.plot. .plot, this is a pandas series. TS, time series, or just arbitrarily named series in pandas. Okay, and you can call plot, and it's going to create basically a line plot. Okay, and when you use pandas, it's going to automatically try to label the axes for you. So here, my index, it's using the index for the x label. It's going to say, oh, this was January 2000, and this was, you know, and so it marks these things off, and here's January 2000, January 2001, January 2002, so on and so forth. There's your axis label. Okay. Here I've got another data frame. Each of these things have kind of some kind of time series in it. Okay. So I've got column A, column B, column C, column D. All right, and I've just created some arbitrary numbers in here. And if I call plot on this, it's automatically going to kind of create line plots for each of these things, automatically label each of the colors with their column headings, okay? And it also automatically provides the axis label, which is quite nice, right? So you could imagine, you know, tracking, say, some stock symbols or something like that. And this would be kind of the plots of, you know, maybe 4 different stocks, how they either go up or down or something like that. Okay. Here, I'm going to just take a single array of values, and I'm going to call kind equals bar. And so this will create a bar with a height of 2.57, a bar with a height of 1.57. This bar is negative, so it actually goes down. We're not accustomed to seeing negative values in a bar chart, but theoretically it could exist, right? And then the last one, 0.626, appears like this. So you can take, you know, kind of one of these rows and then create a bar plot there. Here's a data frame with just some random arbitrary numbers, okay? I guess before I go on, let me give you your last view quiz answer. Last view quiz answer today is A. A as in apple. A as in apple is your last view quiz answer. A as in apple. All right. So here I've got, you could imagine this being some kind of data where we've said, you know, how many instances of, how many companies do we have in the tech sector in California or something, right? I'm just completely making stuff up, okay? So this is just some fake numbers. And what would this look like, right? So I could do plot.bar. So I'm going to call on this data frame, which is just has different, we've got row names from the index and column names. I can call dot plot dot bar, and it's going to create a bar plot. All right, and it's going to kind of create it's going to put the index along the x-axis, and then the columns, it's going to use different colors, and it creates a kind of a side-by-side bar plot for each of these things. If we wanted to go the other way, where we want the columns to kind of form the x-axis, and the different sectors, the different row names to end up being the different colors, I could take the data frame and transpose it. Okay, so I can do df2.transpose and then do .plot.bar, and that will also work. Okay, now the default setting is, you can see the legend gets put inside the plot, which is often undesirable. So what you can do is you can specify where the legend should go. And here I'm going to say bound the box to some anchor location, 1, 1, and this is where it goes. And I forget, we're binding the upper left location of this anchor to something. I forget the exact reasons for this. You can kind of try playing around with this or looking up help on how to do this, but if you want the legend to appear outside of your plot, you would run something like this. Okay. If you don't want all of the bars to show up side by side, you can create a stacked bar. Okay, you can do stacked equals true, and you'll get something like that. Again, you can transpose them and get different things. Here I've got a couple different, a data frame where we have different columns. And here I can call a histogram on each of these things, and it's going to get a histogram for the different columns. So the first column is just random numbers 1 through 6 with equal probability for each one, and then for the second column, I'm taking the numbers and I'm adding just some more values to them, and so we get kind of this triangular distribution for the possible dice roll outcomes. Okay. Anyway, you can take a look at a few more of these examples, right, to see what happens. But here's the this is just kind of your introduction to matplotlib. Okay, we'll end here for today. We will see you guys on Friday. And other than that, have a good day.